Hi guys, so this is a follow-up video to the one we did on Polygon, where we build a program that draws a program that draws a polygon using Vulkan on Android Studio. So our test bed was a physical phone. So this is a follow-up to that video. On this session, we are gonna be drawing Branson's line drawing algorithm. So as you can see, I have already calculated some of the points. We have 5 points to be exact. And we're gonna see the type of method that we are going to interact with that are gonna be helpful when we are drawing this type of line. So in the previous video, we discussed that for vk.draw, we have discussed the vk.draw, which was really helpful when we are drawing, but today the main topic should really lie on topology. So whenever we are drawing a polygon, or really these polynomial figures, we usually utilize a triangle, and the method that is heavily utilized is the topology triangle list especially. But since we are dealing with lines, we no longer need, we don't require this. So the one which we are going to use at the moment is the topology line script. As you can see, it specifies a series of connected primitive in a constant line sharing a vertex. So the vertex is the coordinate that we calculated the Branson. And also, if you are not that familiar with Branson, this is some of the ways you can calculate it. So first, you have to start with you have to have a starting coordinate and a terminal coordinate, which is the ending coordinate. And after, these are usually given, and you have to calculate the steps in between. The next one is that you calculate the change in y and the change in x, which will also lead to you getting the slope. So the third one is deciding the decision parameters. Usually for deciding the decision parameters is usually greater when the decision parameter is greater than 0 or less than 0. So there are usually two use cases. One where the decision variable is below 0, and one where the decision variable is greater or equals to 0 or otherwise. So the first one, we only increment the x-axis, the x coordinate. This is the next sequence of x, and this is the y, the next increment of y. And to calculate the decision variable, we usually take 2 into change of y minus change in x. So you can follow up this video. As you can see, I've already done it, and I was able to get this coordinate. And the exercise that we are solving today is on this part of the session. So we were solving this one where we were told to draw a line using the Bresenham line drawing algorithm from 3.4 to 4.8. So as you can see, our program will not be a dynamic program where you can input values and then calculate it and then draw it, but rather it's already defined set of coordinates that we already have, which is the 3, 4, and 4, 8. So coming back to here, so one of the major things we have to deal with is as you can see, there are many different lines. So how do we differentiate it? Because usually our program usually contains one vk draw, but for this project to be exact, we have to really implement several of them. So as you can see here, the vk.draw buffer, we have the first one, which is which only have two vertices. It only has two vertices, and it only has one instance, and the vertices start from 0. So this one is usually for the x-axis. So we are going to start from, so it's usually starting from here to here. Then we're gonna start, so sorry guys, I don't know, it started following me. So we have to draw from here to here, then from the origin to the to positive 1 in the right side of the x-axis. For the other one, we also draw the y-axis. We start from the, so usually in Vulkan the upper side is negative, while the lower side of the scale is the positive one. So usually these y coordinates we usually convert them to negative. I'm not aware of the specific reason why they choose this, but I think it's usually have to do with something of the transformation formula that they are using, that's usually they have, but I'm not sure at the moment. But that's what we have to really. So as you can see, when we go back to our code, we're gonna have around 4 lines, around 3 lines, because one for the x-axis, one for the y-axis, one for the x-axis, and one for our line, So that's why we have, so the most tricky part that you have to encounter is that the vertices are no longer starting from 0. So if you have created 2 vertices which were starting from 0, the next available, so this one will take 0 and 1, so the next available index is gonna be 2. So you have to, for the y-axis, you have to start index 2 and go up to 3. So for our line, our index is starting from 4. Then we have 5 vertices to be exact, so we are going to up to 9, to index 9, something around there. Sorry, I think index 8, because usually our index starts from 0, so sorry for that one. So the other thing we really have to consider is the topology. As you remember from the last video, we were using VK primitive topology of a line triangles. We are using triangle strips. We are using triangle strips to get connected triangles, so that we could implement our polygon, or we can implement, as you can see right this side of our session, you can see for this rectangle it's made up of 2 triangles, so we need 6 vertices. We require 6 vertices. But at the moment, since we are no longer using that method, we don't have to specify those methods. It's just going to be a straight vertex from one point to another, then from that point to another, from that point to another, so forth until the end of the line. So that's why you utilize the vk.primitive line strip, because we only want a line that connect 2 vertices, and not have a fragment that really comes into play when fragment processing, that really comes to play when shading the region that's drawn by the triangle. Usually whenever we draw a triangle, there is a graphic pipeline that it has to go through until to the end. So at the moment we are just connecting the vertices as we move on. So when we come to the shader part, we are usually defining the x-axis. This is the x-axis from -1. So this is the negative side of the x-axis, while this is the positive side of the x-axis. So this is the positive, although it may seem like negative, but usually in Vulkan, positive side is the one with the negative, and the negative side is the one with the positive. So for our scale here, for so this is going to be help us set us. So this four what so this four position vectors is helping us settle, is helping us draw the is helping us settle the coordinates of our y and x axis. So that helps us to form the grid. So the next part is the how we draw the line. So when we are drawing the line, as we have already seen, we have calculated the Bresenham and calculation the Bresenham line algorithm. We use the the algorithm to get these coordinates. So whenever we get these coordinates, we have to really map onto the Vulkan, onto the phone, onto the specification of the specific phone that we're using at that moment. So as you can see, whenever we have our so as you can see, our coordinates is from 1 to 1, so that's why we have to go on that mapping. Usually usually 1 unit of the window that we have is going to equate to 8 units of our line. So that's why we are dividing 8 through by every one of our coordinates, just to get those coordinates. So 8 is equivalent to 8 units of the line is equivalent to 1 unit. So that's why 8 is the highest, going to be the highest point that we are gonna have. And this is for the color. So for the grid, we went for black, and until this point for the grid it's in black color. So the 4 vertices of the grid are going to have black color, and for the rest this is a light shade blue type theme, but we can so as you can see, we have edited our line to be blue. So this is the program we are at the moment. We can just settle on and build the project as it is. So this is gonna take a while, so let me pause and we will get back to it when we are. So the project is ready now, we can run it. So as you can see, this is our end result whenever we try to take I think the screenshot really brings out the color, because whenever it is this zoomed out you are unable to see the x-axis, but whenever you zoom in it brings all the color, it brings all the colors in. So one more time with the screenshot. So this is our line, and so this is similar to our program right here, where we have drawn this. It goes up 2 times, then it takes a horizontal, it takes a diagonal, then it goes up once more again. So thank you for watching.